Unit 2, Finalizing Design for Booth and Product Windows/Display. Lesson 1, Finalizing Selected Design Using Precise Specifications Provided. Introduction. Once the design brief has been submitted, the design team and clients/supervisors come together to evaluate the proposed ideas and concepts. The submission marks an essential milestone in the design process, as it sets the stage for further collaboration and refinement. The team carefully reviews the brief, ensuring they understand the project's objectives, target audience, brand guidelines, and any other critical details provided. Sample of clients/supervisors' comment. Client: the initial concept looks promising and aligns well with our brand image. However, we would like to see more vibrant colors to add excitement and appeal. Additionally, the product's key features should be highlighted more prominently to draw attention. Looking forward to the next iteration. Supervisor: great start on the design. Let's ensure the layout is optimized for various display sizes and formats. Also, consider incorporating some interactive elements to engage the audience further. Keep up the good work. Analyzing and applying comments. 1. Review and understand. The design team carefully examines the received comments, ensuring they comprehend the specific requests and suggestions from clients or supervisors. This step is crucial in translating feedback accurately into design improvements. 2. Addressing key points. The team focuses on the most critical points mentioned in the feedback. For example, if the client emphasized using vibrant colors and highlighting product features, the team revisits the color palette and adjusts the design layout accordingly. 3. Iterative design process. With the feedback in mind, the designers work on multiple iterations of the design, implementing the suggested changes. Each revision brings the design closer to the client's visions and requirements. 4. Seeking clarifications. If any part of the feedback is unclear, the designers seek further clarification from the clients or supervisors. This ensures that the design process proceeds smoothly and avoids potential misunderstandings. 5. Maintaining consistency. While incorporating feedback, the design team ensures that any changes made align with the brand identity, existing style guidelines, and overall design language. Consistency is vital in presenting a unified and cohesive final product. 6. Test and validate. Before finalizing the design, the team may conduct internal reviews or usability tests to gauge its effectiveness and appeal. Addressing any last-minute tweaks based on these insights further refines the design. 7. Presentation and approval. Once the revised design is ready, the team presents it to the client or supervisor for approval. The process of applying feedback and iterating on the design demonstrates the commitment to meeting the client's expectations and achieving the project's goals. Finalizing a selected design involves a dynamic and iterative process. The collaboration between the design team and clients/supervisors helps ensure that the end product aligns with the initial vision, brand requirements, and specific project objectives. By analyzing and carefully applying feedback, the design reaches its full potential, resulting in a compelling and successful outcome. In this lesson, you will learn the following: providing multi-view orthographic drawings, and finalizing selected booth design. Topic 1: Providing multi-view orthographic drawings. Multi-view orthographic drawings. These types of drawings are crucial in accurately representing three-dimensional objects, such as booths, product windows, and displays, on a two-dimensional surface. These detailed drawings provide valuable information to designers, manufacturers, and stakeholders, ensuring precise execution and adherence to project requirements. Let us explore the key elements involved in providing multi-view orthographic drawings. Types of views: front view, top view, side view. Multi-view orthographic drawings typically consist of three primary views: the top view, front view, and side view. These views showcase the object from different perspectives, offering a comprehensive understanding of its form and dimensions. The top view illustrates the object from above, the front view displays it from the front-facing side, and the right side view presents the object from the right side, indicating accurate booth and product window/display size and dimensions. Accurate measurement is vital in multi-view orthographic drawings. Dimensions, both external and internal, must be precisely indicated to provide clear information about the size and proportions of the booth, product window, or display. Proper scaling ensures that the representation is true to the actual physical object, helping designers and manufacturers create an exact replica. Indicating materials and specifications. Alongside dimensions, multi-view orthographic drawings should indicate the materials and specifications to be used in constructing the booth, product window, or display. Callouts or annotations can be added to highlight the material's characteristics, such as texture, color, and finishing, aiding in the execution process. Following branding guidelines. For brand-oriented projects, adhering to branding guidelines is crucial in multi-view orthographic drawings. Incorporating brand elements like logos, color schemes, typography, and other visual cues ensures consistency with the brand's identity. Aligning the design with the brand guidelines helps maintain a unified brand image across different marketing materials and physical displays. Benefits of multi-view orthographic drawings. 1. Precise communication. Multi-view orthographic drawings provide a clear and standardized method of communication between designers, manufacturers, and clients. Misinterpretations are minimized, leading to accurate implementation. 2. Enhanced visualization. Orthographic drawings offer an in-depth visualization of the object's dimensions and features from multiple angles, helping stakeholders gain a comprehensive understanding of the final outcome. 3. Error reduction. By providing detailed dimensions and specifications, multi-view orthographic drawings reduce the likelihood of errors during the construction or fabrication process. 4. Streamlined production. Manufacturers can easily translate multi-view orthographic drawings into production plans, streamlining the manufacturing process and reducing production time. Topic 1. Providing multi-view orthographic drawings. Dimension of the booth in different views. Common booth dimensions. Exhibition spaces vary in dimensions based on factors such as event type, location, availability, and cost. Nevertheless, the trade show industry typically recognizes a few sizes as standard. 3m×3m, 10x10, booth size. This is the most commonly used and readily available booth size at many trade fairs. Booth configurations are typically inline or corner. It is crucial to familiarize yourself with the layout in advance for effective planning. As a general guideline, your displays should be smaller than the booth size to ensure a proper fit. 3m×6m, 10x20, booth size. Booths of this size often feature a peninsula configuration, consistently measuring 6m in width and 3m in depth. This setup provides additional space for displays and offers a greater opportunity to impress your audience. While these booths may come at slightly higher cost, the investment is worthwhile. 6m×6m, 20x20, booth size. These booths are classified as island booths, being the largest and most expensive. The generous dimensions allow for a substantial crew, ample storage, and extensive display space. The design and size of these booths enable a powerful visual impact on your audience. Standard booth sizes vary to accommodate different needs and budget. Smaller 3m×3m booths are common and cost-effective, while larger 6m×6m island booths offer greater space and visual impact. The choice of booth size depends on your specific goals and resources for the exhibition. Different views of a booth can provide various dimensions and perspectives. Here are the dimensions typically associated with different views of a booth. Floor plan view. Plan view. This is a top-down view of the booth, showing the layout and dimensions of walls, partitions, and fixtures. It provides a bird's-eye view of the booth's footprint and how the space is organized. Elevation views. Front elevation. This view shows the booth's front-facing dimensions, including the height and width of the display area or signage. Side elevation. Side elevation views depict the booth's dimensions from the side, including height and width, and can be useful for understanding the booth's profile. Topic 2. Finalizing selected booth design. Once the design brief for the Bobcare Optical Incorporated booth and product window/display has been received, the design team proceeds to identify the specific needs and requirements based on the outlined objectives and specifications. The following key aspects should be addressed during the finalization process. Alignment with project objectives. Ensure that the finalized booth design effectively showcases Bobcare Optical's diverse product lineup, including stylish eyewear and innovative eye care services. The design should captivate and educate the target audience, which comprises customers, eyewear enthusiasts, industry professionals, and the media. Emphasize the promotion of the newly created website as a hub for online shopping, eye care resources, and customer engagement. Adherence to design specifications. Confirm that the finalized design aligns with the specifications outlined in the project brief, including the requirement for a peninsula booth measuring 20 feet by 10 feet, 6 meters by 3 meters. Ensure that the booth design utilizes the available space efficiently to accommodate larger displays and interactive elements. Integration of multi-view orthographic drawings. Provide detailed multi-view orthographic drawings of the selected booth design. These drawings should accurately depict the layout, dimensions, and placement of various elements within the booth. Incorporation of 3D mockup and rendered graphics. Create a 3D mockup of the booth design to visualize its appearance from different perspectives. Use rendered graphics to enhance the visual presentation and convey the ambience of the booth environment. Development of scaled prototype. Produce a scaled prototype, mini version, of the booth design to assess its physical attributes and functionality. The scaled prototype serves as a tangible reference point for evaluating the design's feasibility and making any necessary adjustments. Brand consistency and messaging. Ensure that the booth design reflects Bobcare Optical's brand identity and messaging consistently. Incorporate signage, print materials, and visual elements that effectively communicate the benefits of the company's vision care services and eyewear products. Documentation and approval process. Prepare comprehensive documentation of the finalized booth design, including detailed specifications, materials, dimensions, and utility plans. Submit the final design package to the client and/or supervisor for approval, allowing for feedback and revisions as necessary within the established timeline of 1 month. By following the requirements closely, you can make the best use of resources, reduce scope creep, and boost client satisfaction, paving the way for trust and future collaborations. Lesson 2: Producing 3D model images/view of the approved design. Introduction. In 3D computer graphics and modeling, various views and illustrations are used to represent and visualize objects in three-dimensional space. These views provide different perspectives and insights into the object's structure, shape, and orientation. Here are some of the common 3D model views and illustrations. Wireframe view. This displays the 3D model as a collection of lines and vertices, representing only the basic structure without any surface or texture information. This view is useful for understanding the object's overall form and typology. Solid view. The 3D model is displayed as a complete, opaque object with its surfaces and textures visible. This view provides a realistic representation of the object. Shaded view. This refers to the process of adding color or grayscale to the 3D model's surfaces to enhance the visual representation. A shaded view can be either flat shading, uniform color across each polygon, or smooth shading, smooth transition of colors across the surface. Orthographic view. In this view, the object is presented without any perspective, meaning there is no foreshortening or vanishing point. It provides a precise representation of the object's dimensions and is commonly used in technical drawings. Isometric view. This shows the 3D model from an angle where all three axes, X, Y, and Z, are equally foreshortened. This results in a distorted perspective but allows for a clear representation of the model's dimensions. Perspective view. This shows the 3D model with realistic depth and foreshortening, simulating how the object would appear in the real world. The components become small when further away, while components that are close become larger. This view is commonly used in rendering and visualizations. Section view. This view displays a cross-sectional slice of the 3D model. However, in a cutaway view, part of the exterior is removed, providing a better view of the internal components. Exploded view. This view shows the individual components of a complex assembly separated from each other. It is often used in technical illustrations to demonstrate how the different parts fit together. Ghosted view. This view displays a semi-transparent representation of the 3D model, allowing you to see both the exterior and interior of the object simultaneously. These views and illustrations are widely used in various industries, such as engineering, architecture, video games, animation, and product and booth design, to visualize and communicate 3D models effectively. In this lesson, you will learn the following. Using the basic tools of different 3D software. Creating the 3D model. Saving and exporting the file. Creating the booth mockup, and presenting 3D model and documentation of final design. Topic 1. Using the basic tools of different 3D software. Creating a precise colored 3D model image of a booth or window display involves a detailed and systematic approach. Below is a step-by-step process to achieve this using an industry-standard 3D modeling software, taking into account computer-assisted techniques for sustainability and adhering to the provided design brief. Using the basic tools of Blender. Before we can create a 3D, let us first be familiarized with the software tools and how to use them. Since there are plenty of software to be used, let's try SketchUp and Blender. Using the basic tools of SketchUp. Using the basic tools of Blender. Topic 2. Creating the 3D model. Now, since you have been introduced to the basic tools in SketchUp, let's try making a 3D booth using the software. Let's use the details of our design brief to create the design of the booth. Creating a 3D model for the booth design. Topic 2. Creating the 3D model. Things to remember when creating a 3D model. Here are the things you will need to take note when creating the 3D model of the booth. 1. Read and analyze the design brief thoroughly to grasp the project's requirements, including dimensions, materials, color scheme, branding elements, and any specific features requested for the booth or window display. 2. Gather reference materials such as concept sketches, photographs, and any other visual references that can aid in understanding the design and aesthetics desired in the final 3D model. 3. Choose an industry-standard 3D modeling software that supports accurate scaling and advanced rendering capabilities. Options include Autodesk 3ds Max, Blender, Cinema 4D, or similar software that suits your proficiency level. 4. When creating a new document, set the units to match the design brief's requirements, e.g., millimeters or inches, to ensure precise scaling of the model. 5. Import architectural drawings or create a base geometry of the booth or window display using basic shapes and tools in the software. Ensure that the proportions and dimensions align with the design brief. 6. Make sure to refine the base geometry, adding details and features based on the design brief and reference materials. Pay attention to accurate measurements and maintain clean, organized modeling practices. 7. Make use of the software's material editor. Apply appropriate colors, textures, and finishes to the 3D model. Match the materials with the design brief and reference materials for realistic representations. 8. Do not forget to incorporate branding elements, logos, and any graphics specified in the design brief onto the 3D model. Ensure they are accurately placed and aligned as per the design requirements. 9. Create a lighting setup for the scene to simulate the intended environment for the booth or window display. Experiment with the different light setups to achieve the desired ambience and visual impact. Include shadows and reflections to add realism to the image. 10. To ensure sustainability, optimize the 3D model's geometry and use efficient rendering settings that strike a balance between quality and resource consumption. Avoid unnecessary details that will not be visible in the final image. 11. Try to produce test renders of the 3D model from various angles to evaluate the composition, lighting, and overall visual appeal. Make any necessary adjustments based on the results. 12. Once satisfied with the 3D model and scene setup, configure the rendering settings for the final output. Choose the appropriate resolution and file format for the image. 13. Make sure to initiate the rendering process to generate the high-quality, colored 3D model image. Depending on the complexity of the scene and the hardware, this may take some time. Topic 3. Saving and exporting the file. File saving and exporting. After you finish developing the 3D model of the booth, make sure to save and export the file. Topic 4. Creating the booth mockup. To better understand and showcase the booth design, let's try to create a mockup. Topic 5. Presenting 3D model and documentation of the final design. Your job involves more than just designing the booth. You will also need to present your design and its parts to the client. Below is the general process on how you can present your 3D booth design. Step 1. Review the checklist of completion. Ensure that your brand's logo is visible and appropriately placed in the presentation. Verify that the colors used in your 3D model images align with your brand's color palette. Check that the reflections and shadows in the 3D model images enhance the presentation's realism. Step 2. Prepare the presentation structure. Start with an introduction slide that gives an overview of the project including its purpose and objectives. Organize the presentation into sections to cover the different aspects: branding, structure, functionality, materials, and utilities. Create a flow that logically progresses from one section to another, making it easy for the audience to follow. Step 3. Indicate the branding. Introduce your brand and its values before delving into the design specifics. Showcase the brand logo on the title slide and, if relevant, on each subsequent slide. Emphasize the consistent use of brand colors throughout the presentation. Step 4. Present the structure and functionality. Begin by providing an overview of the design structure, explaining the key components and their roles. Use 3D renders, diagrams, or animations to illustrate the design's form and layout effectively. Collaborate with relevant personnel, engineers, architects, etc., to gather accurate and detailed information about the design's functionality. Incorporate their input to create clear visuals or animations that demonstrate how the design works. Step 5. Indicate required materials. Create a list of all materials used in the final design. Provide images or samples of the materials to give the audience a tactile understanding. Explain the properties and advantages of each material, emphasizing how they contribute to the overall design. Step 6. Present electrical, lighting, and other utilities. Describe the electrical components, circuits, and systems incorporated into the design. Include electrical schematics or diagrams to illustrate the connections and layout. Highlight the lighting solutions integrated into the design and explain how they enhance the user experience. If other utilities are essential, e.g., plumbing, ventilation. Outline their roles and how they complement the design. Step 7. Showcase the 3D model. Display your 3D model from multiple angles to provide a comprehensive view. Utilize animations or interactive features to showcase the design's functionality. Use callouts or annotations to explain specific features and design decisions. Step 8. Address potential questions. Dedicate a section of the presentation to address potential questions and concerns from the audience. Be prepared to explain design choices, material selection, and how utilities are integrated. Step 9. Conclude the presentation. Summarize the key points covered in the presentation. Reiterate the importance of the design's functionality, materials, and utilities in achieving the project's objectives. Thank the audience for their attention and invite any additional questions or feedback. Step 10. Share documentation. After the presentation, provide the audience with a copy of the documentation, including detailed schematics, material specifications, and any other relevant data. O. Offer contact information for further inquiries or collaboration opportunities. By following this structured presentation approach, you can effectively communicate your 3D booth design to the client, build confidence in your expertise, and foster a collaborative working relationship.